Time flows like a quiet river through our consciousness, marking the gentle rhythm of our days and the deeper patterns of our lives. Yet for all its familiarity, time remains one of the most profound mysteries in all of science. What exactly is this invisible force that carries us from moment to moment, from breath to breath, from thought to thought? Imagine yourself lying in a meadow on a warm summer afternoon, watching clouds drift slowly across the sky. The grass beneath you sways gently in the breeze, and somewhere in the distance you hear the soft ticking of nature's own clock, perhaps the rhythmic call of a bird or the whisper of wind through leaves. In this peaceful moment, time seems to stretch and bend, moving more slowly than the hurried seconds of our busy lives. This isn't just your imagination. It's a glimpse into one of the most beautiful truths about time itself. Albert Einstein, that gentle genius with wild hair and kind eyes, discovered something remarkable about time over a century ago. Time, he realized, is not the rigid, unchanging metronome we once believed it to be. Instead, it's more like a flowing stream that can speed up or slow down depending on where you are and how fast you're moving. When you're in love, an hour spent with someone special can feel like minutes. When you're waiting for important news, minutes can stretch like hours. Einstein showed us that this subjective experience of time reflects something deeper and more fundamental about reality itself. In Einstein's elegant theory of relativity, time becomes intimately connected with space, forming what physicists call space-time, a soft, flexible fabric that can be stretched and compressed like a gentle blanket. Imagine this cosmic blanket spread across the universe, with planets and stars resting upon it like smooth stones on silk. The heavier the stone, the deeper it sinks into the fabric, creating gentle curves and valleys that guide the motion of everything around it. This is how gravity works, not as a force pulling things together, but as the natural result of objects following the curved pathways through space-time. But what makes time so special, so different from the 3 dimensions of space we can walk through and touch? The answer lies in time's arrow, its seemingly unstoppable flow from past to future. Unlike space, where we can move freely backward and forward, left and right, up and down, time carries us in only one direction. We remember yesterday, but not tomorrow. We can influence the future, but not the past. This asymmetry gives time its profound meaning in our lives and in the workings of the universe. Scientists believe this arrow of time emerges from a deep principle called entropy, the tendency of systems to become more disordered over time. Picture a perfectly organized bookshelf with every volume in its proper place. Leave it alone, and gradually dust will settle, books will shift, perhaps a few will fall. The organized state naturally evolves toward disorder, creating the forward flow of time we experience. On a cosmic scale, the entire universe began in a state of incredible order, all its energy and matter compressed into an infinitesimally small point. Since the Big Bang, that initial order has been gradually spreading out and cooling down, creating the river of time in which we swim. Yet time's mysteries run even deeper. In the quantum realm, the world of atoms and particles, time behaves in ways that challenge our everyday understanding. Particles can exist in multiple states simultaneously, as if experiencing several timelines at once, until the gentle act of observation causes them to choose a single path. Some physicists wonder if time itself might be an illusion, a useful concept that emerges from something more fundamental, like the way temperature emerges from the motion of countless invisible molecules. Think about your own experience of time during different states of consciousness. In deep sleep, hours pass in what seems like moments. In dreams, time becomes fluid and strange. You might experience entire lifetimes in a single night's rest, or find yourself moving backward through memories, or forward into impossible futures. Even in waking life, time's passage varies with our attention and emotion. When we're deeply absorbed in a beautiful sunset or a meaningful conversation, time seems to pause. When we're bored or anxious, it crawls. This subjective nature of time points to something profound about consciousness itself. Our brains construct our experience of time from a complex weaving of memory, attention, and expectation. The present moment, the now you're experiencing as you listen to these words, is actually a construction of your nervous system, a brief window of awareness that stitches together the immediate past and the anticipated future into a coherent sense of being. Modern physics has revealed that time is far stranger and more beautiful than our ancestors ever imagined. Near massive objects like black holes, time slows down relative to distant observers. Travel close to the speed of light, and time dilates, stretching like warm honey. These aren't just theoretical curiosities, they're effects we must account for in GPS satellites to maintain their accuracy. Reminders that Einstein's insights touch our daily lives in countless invisible ways. As you drift towards sleep tonight, let your mind wander through this river of time. Feel the gentle current carrying you from the busy thoughts of today toward the peaceful rest of night. Time is not your enemy, rushing you toward deadlines and demands. It's the very medium of existence itself, the canvas on which consciousness paints its masterpiece of experience. In understanding time, we come to understand something essential about ourselves and our place in the vast, gentle cosmos that holds us all. The next time you find yourself stressed about time, feeling like there's never enough or that it's moving too quickly, remember Einstein's revelation. Time is not separate from you. It's woven into the very fabric of your being. You are not just traveling through time, you are part of time's eternal dance, a conscious note in the symphony of space-time that has been playing since the universe began its journey from that first moment of creation. Twilight settles over the world, and your eyelids grow heavy. Your brain begins preparing for one of nature's most extraordinary performances. Behind closed eyes, in the soft darkness of sleep, an entire universe awakens. This is the realm of dreams, that mysterious theater where memories dance with imagination, where the impossible becomes commonplace, and where your mind weaves stories more vivid and strange than any film ever created. What exactly happens in your brain during those precious hours of sleep? Picture your mind as a vast, quiet library after closing time. During the day, this library buzzes with activity. Librarians rushing about, filing new information, retrieving old memories, processing the constant stream of sensory input from the world around you. But when sleep arrives, a different kind of work begins. The night shift takes over, and their job is perhaps even more important than the day's busy activities. Scientists have discovered that sleep is far from the passive, empty state we once believed it to be. Instead, it's an active, purposeful process where your brain performs essential maintenance and organization. Think of it like a gentle janitor moving through the corridors of your mind, tidying up the day's experiences, filing away important memories, and clearing out unnecessary clutter. This process is so crucial that every known animal species sleeps in some form, despite the apparent vulnerability it creates. The journey into sleep unfolds in stages, each with its own character and purpose. As you first drift off, your brainwaves slow from the rapid beta waves of waking consciousness to the gentler alpha waves of relaxation. Your muscles begin to release their tension, your breathing deepens, and your heart rate slows. This is like stepping from the bright, busy street into a peaceful library. The transition from the external world to the inner sanctum of rest. Deeper into sleep, you enter what scientists call slow-wave sleep, characterized by the long, rolling delta waves that sweep across your brain like gentle ocean swells. During this phase, your brain is working quietly but intensely, consolidating the day's learning and experiences. The temporary storage areas of your mind transfer important information to more permanent vaults of memory. It's during this deep, restorative sleep that your brain quite literally cleans itself, flushing out metabolic waste through a recently discovered system called the glymphatic network, a neural cleaning crew that becomes 10 times more active during sleep. But perhaps the most fascinating phase of sleep is REM, rapid eye movement sleep, where most of our vivid dreams occur. During REM sleep, your brain becomes almost as active as it is during waking hours, yet your body remains peacefully paralyzed, preventing you from acting out your dreams. Behind your closed lids, your eyes dart back and forth, as if watching an invisible movie, which, in many ways, they are. Dreams themselves are one of consciousness's greatest mysteries. Why do we dream? What purpose do these strange, often surreal narratives serve? Modern neuroscience suggests that dreams are far more than random neural static. They appear to be your brain's way of processing emotions, solving problems, and integrating new experiences with existing knowledge. Dreams provide a safe space where your mind can explore possibilities, work through fears, and make unexpected connections between seemingly unrelated ideas. Consider the architecture of a typical dream. Logic often takes a back seat to emotion and symbolism. You might find yourself flying through familiar places that somehow aren't quite right, or having conversations with people who shift and change like water. Time becomes fluid. You might experience your childhood home as it exists now, or encounter people from different periods of your life, all together in one impossible scene. This isn't malfunction, it's feature. Dreams allow your brain to think outside the rigid constraints of waking logic, potentially leading to creative insights and emotional breakthroughs. The emotional content of dreams is particularly significant. The amygdala, your brain's alarm system for detecting threats and strong emotions, remains highly active during REM sleep. This may explain why dreams often have such intense emotional coloring, and why they frequently involve scenarios that trigger fear, anxiety, joy, or love. Through dreams, your brain may be practicing responses to emotional situations, helping you develop resilience and emotional intelligence. Some of history's greatest discoveries have emerged from dreams. Auguste Kekule claimed the structure of benzene came to him in a dream of a snake seizing its own tail. Dmitri Mendeleev supposedly saw the complete periodic table in a dream after struggling with its organization for days. These weren't mere coincidences, but examples of the dreaming brain's unique ability to form novel connections and see patterns that elude our waking minds. The neuroscience of dreaming reveals a beautiful orchestration of brain regions working in concert. The visual cortex creates the imagery. The emotional centers add feeling and meaning, while the prefrontal cortex, responsible for logic and self-awareness, remains relatively quiet. This explains why dreams can feel so real and meaningful in the moment, yet seem bizarre upon waking, when our logical minds reassert themselves. Even the act of forgetting dreams serves a purpose. Most dreams fade quickly upon waking, like morning mist dissolving in sunlight. This forgetting isn't a failure of memory, but a protective mechanism. If we retained every dream with the same vividness as waking experiences, the boundaries between reality and imagination might become uncomfortably blurred. Instead, dreams influence us subtly, leaving behind emotional residues and unconscious insights that shape our waking thoughts and behaviors. Sleep and dreams also play crucial roles in learning and creativity. Students who sleep after learning new material often perform better on tests than those who stay awake. Artists and writers frequently report that their most innovative ideas come after a good night's sleep, when their brains have had time to make unexpected connections between disparate pieces of information. As you prepare for sleep tonight, embrace the approaching journey into this inner world your dreams await, not as mere random firings of neurons, but as meaningful expeditions into the depths of your own consciousness. In dreams, you become both the author and the audience of stories uniquely your own, tales woven from the threads of memory, emotion, and imagination. Let yourself drift into this nightly theater, trusting in the ancient wisdom of sleep to restore, refresh, and perhaps surprise you with insights that daylight never could provide. In the vast theater of the cosmos, there exists a speed limit so fundamental, so deeply woven into the fabric of reality itself, that it governs everything from the smallest quantum particles to the largest galactic structures. This is the speed of light, not merely fast, but representing something far more profound. The very architecture of space-time and the boundary between what is possible and what is not in our universe. Picture yourself standing on a quiet beach at sunset, watching the last golden rays stretch across the water toward you. Those photons of light, born in the nuclear furnace of the sun some 8 minutes ago, have traveled nearly 93 million miles to reach your eyes. They made this incredible journey at exactly 299,792,458 meters per second. A number so precise and unchanging that we now use it to define the meter itself. But why this speed? Why not faster? Why not slower? The answer takes us to the very heart of what it means to exist in our universe. Light's speed limit isn't really about light at all. It's about the fundamental structure of space-time, that four-dimensional fabric we discussed earlier, where space and time are woven together into a single unified reality. The speed of light is actually the speed of space-time itself, the rate at which cause and effect can propagate through the universe. It's the cosmic speed limit, not because light is special, but because light happens to be massless and therefore able to achieve this ultimate velocity. Imagine space-time as a vast ocean, calm and serene in the deep cosmic night. When something happens, a star explodes, a particle decays, a thought forms in your mind. It creates ripples in this ocean. These ripples carry information about the event outward in all directions, but they can only travel so fast. The speed of light is the speed of these ripples, the maximum rate at which information can flow from one part of the universe to another. This cosmic speed limit creates what physicists call the light cone, a beautiful geometric shape that defines the boundaries of causality itself. Picture an hourglass lying on its side, stretching infinitely in both directions. You exist at the narrow waist of this hourglass, in the present moment. The upper half represents all the events in space-time that could potentially influence you, your past light cone. The lower half contains all the events you could potentially influence, your future light cone. Everything outside these cones exists in what we might call elsewhere, regions of space-time that are causally disconnected from your present moment. This isn't just abstract physics. It has profound implications for how we understand reality, the conversations you have, the decisions you make, the love you feel. All of these create ripples that spread outward at the speed of light, gradually expanding their influence on the universe. Meanwhile, events happening right now on distant stars cannot affect you until their light has had time to travel across the vast spaces between us. In a very real sense, the speed of light determines the boundaries of your immediate universe, the sphere of space-time from which you can receive information and into which you can send it. Einstein's revelation about the speed of light led to one of the most beautiful and counterintuitive discoveries in all of physics: time dilation. As objects approach the speed of light, time itself begins to slow down relative to outside observers. This isn't a mechanical effect of moving clocks running slowly. It's a fundamental property of space-time itself. Time and space are so intimately connected that motion through space affects the flow of time. Consider the peaceful journey of a photon, a particle of light traveling from a distant star to your eye. From the photon's perspective, if it could have a perspective, the journey takes no time at all. At the speed of light, time dilates infinitely, and space contracts to zero. The photon experiences its entire journey, perhaps lasting millions of years from our perspective, as a single timeless instant. It's born and absorbed in the same eternal moment, existing in a state beyond time as we understand it. This speed limit also reveals something profound about mass and energy. As objects with mass approach the speed of light, their energy requirements become infinite. It would take all the energy in the universe to accelerate even a single electron to light speed. This isn't a technological limitation. It's a fundamental feature of reality. Mass and the speed of light are connected through Einstein's famous equation E equals mc squared, which tells us that mass and energy are different forms of the same thing. The speed of light squared, that enormous number, is the conversion factor between mass and energy, explaining why even tiny amounts of matter can release tremendous energy when converted, as happens in the hearts of stars. But the universe has found beautiful ways to dance with this cosmic speed limit. While nothing with mass can reach light speed, space itself has no such restriction. During the rapid expansion following the Big Bang, space itself stretched faster than light, carrying distant galaxies beyond our observable horizon. Even today, the most distant galaxies are receding from us faster than light due to the expansion of space, not because they're moving through space at impossible speeds, but because space itself is growing between us. Quantum mechanics adds another layer of mystery to light's speed limit. Quantum entanglement allows particles to maintain instantaneous correlations across any distance, seeming to violate the prohibition against faster-than-light communication. Yet the universe maintains its cosmic speed limit through a subtle principle. While the correlations are instantaneous, no information can actually be transmitted faster than light through these quantum connections. It's as if the universe has a built-in censorship mechanism protecting causality itself. The speed of light also defines the edge of our observable universe. Since light from the most distant objects has had only about 13.8 billion years to reach us since the Big Bang, we can only see objects within this cosmic horizon. Beyond lies the unobservable universe, regions of space-time that exist but remain forever hidden from our view by the fundamental speed limit of reality itself. As you rest tonight, consider the gentle rain of photons falling on your closed eyelids. Perhaps starlight that began its journey years ago, carrying information from distant suns across the cosmic ocean of space-time. These particles of light represent more than mere illumination. They are messengers of the universe's deepest truths, traveling at the one speed that connects all things, defines all possibilities, and sets the rhythm by which the cosmos dances through space and time. Cosmic gardens, the birth, life, and legacy of galaxies. In the deepest darkness of space, far beyond the gentle glow of our own Milky Way, countless islands of light drift through the cosmic ocean like luminous seeds scattered by an invisible gardener. These are the galaxies, vast collections of stars, gas, and dust that represent some of the most magnificent structures in the known universe. Each galaxy is a world unto itself, containing billions or even trillions of stars. Yet from our distant perspective, they appear as soft, ethereal spirals and ellipses, glowing gently against the velvet backdrop of space. The story of galaxies begins in the earliest moments after the Big Bang, when the universe was a smooth, nearly featureless expanse of hot gas. Picture the cosmos as a calm lake on a windless morning, its surface barely disturbed by the tiniest ripples. These subtle variations in density, fluctuations so small they would have been invisible to any observer, were the seeds from which all cosmic structure would eventually grow. Like gentle waves spreading across still water, these density fluctuations grew slowly under the patient influence of gravity. For hundreds of millions of years, the universe existed in what cosmologists poetically call the Dark Age, a time when no stars had yet formed to illuminate the cosmic darkness. The first galaxies were born during this primordial night, as gravity gathered the universe's sparse matter into increasingly dense clouds. These early galactic nurseries were very different from the majestic spiral galaxies we see today. They were smaller, more chaotic, and filled with the very first generation of stars, massive, brilliant giants that burned through their nuclear fuel in mere millions of years before exploding in spectacular supernovas. Imagine watching one of these primordial galaxies form, like observing a time-lapse film of a garden growing from bare soil. At first, you might see only darkness, punctuated by the occasional flash of light as the first massive stars lived their brief, violent lives. But with each stellar death, the galaxy became richer and more complex. The supernovas scattered heavier elements, carbon, oxygen, silicon, iron, into the surrounding gas, fertilizing the cosmic soil for future generations of stars and planets. As eons passed, galaxies began to take on the familiar shapes we recognize today. The graceful spiral arms of galaxies like our own Milky Way are not rigid structures, but rather waves of star formation that sweep around the galactic center like slow-motion whirlpools. These spiral waves compress the gas and dust in their path, triggering the birth of new stars that shine brilliantly blue and white before the wave moves on, leaving behind older, redder stars. From a distance, this creates the beautiful spiral pattern, bright arms outlined by young, hot stars, with older stellar populations filling the spaces between. The heart of every galaxy contains one of the universe's most mysterious objects, a supermassive black hole. These cosmic giants, millions or billions of times more massive than our Sun, sit like sleeping dragons at the galactic center. Despite their fearsome reputation, these black holes play a crucial role in galactic evolution. As matter spirals into them, it forms an accretion disk that can shine brighter than all the galaxy's stars combined, creating what astronomers call an active galactic nucleus. The energy released by this process can trigger or suppress star formation throughout the galaxy, like a cosmic thermostat, regulating the galaxy's metabolism. Galaxies are not solitary wanderers, but social creatures that exist in vast communities. They cluster together in groups and clusters, bound by gravity into structures that can span hundreds of millions of light years. Within these clusters, galaxies interact in a graceful, slow-motion dance that unfolds over hundreds of millions of years. Sometimes they pass close enough to distort each other's shapes through tidal forces, pulling out long streams of stars like cosmic hair, flowing in an invisible breeze. Other times, smaller galaxies merge with larger ones, adding their stars to the growing galactic metropolis. Our own Milky Way is currently engaged in such a dance with its nearest major neighbor, the Andromeda Galaxy. These two spiral galaxies are approaching each other at over 250,000 miles per hour, and in about 4.5 billion years, they will merge into a single, larger galaxy that astronomers have whimsically named Milkomeda. This might sound catastrophic, but the merger will be surprisingly gentle. The vast distances between stars mean that actual stellar collisions will be rare. Instead, The two galaxies will interpenetrate like ghost ships passing through each other, their gravitational interactions gradually settling into a new, stable configuration. The life cycle of a galaxy spans tens of billions of years, far longer than the current age of the universe. Young galaxies burn through their gas reserves rapidly, forming stars at a frenzied pace. As they mature, their star formation rate slows, and they begin to take on the redder hues of older stellar populations. Eventually, a galaxy may exhaust its supply of star-forming gas, entering a kind of cosmic old age where no new stars are born, and the existing stars gradually fade and die.
But even this is not the end of the story. Galaxies can be rejuvenated by encounters with their neighbors, which can funnel fresh gas into their centers and trigger new waves of star formation. They can also capture smaller galaxies, adding fresh material and extending their active lifespans. In this way, galaxies grow and evolve through cosmic time, becoming larger and more complex as the universe ages. The study of galaxies has revealed one of the most profound mysteries in modern astronomy: dark matter. The visible stars and gas in galaxies account for only a small fraction of their total mass. The rest, about 5 times more, consists of some unknown form of matter that doesn't emit light, but makes its presence known through its gravitational effects. This dark matter forms vast, invisible halos around galaxies, providing the gravitational scaffolding that holds these cosmic structures together and guides their evolution. Perhaps most remarkably, galaxies are the crucibles in which the elements of life are forged. The carbon in your cells, the oxygen you breathe, the iron in your blood, all were created in the nuclear furnaces of stars within galaxies and distributed through space by stellar winds and supernova explosions. In a very real sense, we are made of processed starlight, our bodies composed of atoms that were once part of distant suns in the cosmic garden of the Milky Way. As you drift towards sleep tonight, imagine yourself floating gently above our galaxy, seeing it spread out below you, like a vast pinwheel of light turning slowly in the cosmic darkness. Feel yourself as part of this grand structure, connected to every star and planet through the bonds of gravity and the shared history of cosmic evolution. You are not separate from the universe, but woven into its very fabric, a conscious expression of the same creative forces that give birth to stars and shape the destiny of galaxies across the endless expanse of space and time. The Wanderer's Tale, water's epic journey through Earth and time.
Close your eyes and listen to the gentle sound of rain against a window, or perhaps the soft babbling of a distant stream. In these simple, peaceful sounds lies one of the most extraordinary stories ever told. The tale of water, the wandering molecule that has shaped our planet and made life itself possible. Every drop that falls from the sky, every sip you take, every wave that laps against a shore, carries within it a history spanning billions of years and countless journeys around our blue planet. Water is perhaps the most familiar substance on Earth, yet it remains one of the most mysterious and remarkable.
Unlike almost any other material we encounter, water exists in all three states: solid, liquid, and gas, within the narrow temperature range found on our planet's surface. This simple molecule, just two hydrogen atoms embracing a single oxygen atom, possesses properties so unusual that if we discovered it on an alien world, we would marvel at its strangeness. Yet here on Earth it flows through our rivers, fills our oceans, and courses through our very veins, with such constancy that we rarely pause to consider its miraculous nature. The story of Earth's water begins in the cosmic nursery, where our planet formed some 4.5 billion years ago. Picture the early solar system as a swirling disk of dust and gas, lit by the young sun's fierce radiation. As gravity gathered this material into the worlds we know today, water arrived through two great deliveries. Some came locked within the rocky materials that built our planet. Water molecules, trapped in crystal structures, released slowly as the Earth heated and differentiated. But much of our precious water arrived later, carried by countless comets and asteroids that rained down during a period called the Late Heavy Bombardment. These cosmic messengers, these wandering icebergs of the outer solar system, brought with them the gift of oceans. Each impact added to Earth's growing reservoir of water. And over millions of years, as the planet cooled and stabilized, this water began to condense from the steamy atmosphere. Imagine those first gentle rains falling on a young world of volcanic rock, pooling in the low places, gradually filling the basins that would become our first seas. But water's true magic lies not in its cosmic origins, but in its extraordinary behavior here on Earth. Water is one of the few substances that becomes less dense when it freezes, which is why ice floats. The seemingly simple property has profound consequences for life on our planet. When lakes and oceans freeze in winter, the ice forms an insulating blanket on the surface, protecting the liquid water and the life within it from the harsh cold above. Without this unusual property, bodies of water would freeze solid from the bottom up, creating a world where liquid water could only exist during the warmest periods. Water's ability to dissolve more substances than any other liquid has earned it the title of universal solvent. This remarkable property allows water to carry nutrients to every cell in your body, transport minerals through soil to nourish plants, and shape the very face of our planet through the slow but persistent process of erosion. The Grand Canyon, that magnificent scar across the American Southwest, is essentially a testament to water's patient persistence. The Colorado River and its tributaries, carving through solid rock grain by grain, drop by drop, over millions of years. Perhaps most remarkably, water has the ability to moderate temperature through its high specific heat capacity. It takes a tremendous amount of energy to heat water, and it releases that energy slowly when cooling. This thermal inertia means that oceans act as vast heat reservoirs, storing warmth from summer to winter, from day to night, and even from one year to the next. Without this moderating influence, Earth's temperatures would swing wildly between scorching heat and bitter cold, making our planet far less hospitable to life. The water cycle, that endless circulation of moisture between sea and sky and land, is perhaps nature's most beautiful example of recycling. Powered by the sun's energy, water evaporates from oceans, lakes, and rivers, rising invisibly into the atmosphere as water vapor. As this moisture-laden air cools, the vapor condenses around tiny particles of dust and salt, forming the clouds that drift across our skies like floating islands. When conditions are right, these clouds release their cargo as rain or snow, beginning water's journey back to the sea through streams and rivers, or seeping into the ground to join the vast underground reservoirs we call aquifers. This cycle means that the water in your morning coffee might once have fallen as snow on ancient mountains, flowed in rivers that no longer exist, or been part of the vast primordial oceans where life first stirred. Every water molecule on Earth is a time traveler, carrying within it the memory of countless journeys. The water in your body has been rain and river, cloud and ocean, ice and vapor. It has nourished forests and filled seas, been drunk by dinosaurs and absorbed by flowers that bloomed millions of years ago. Life itself arose in water's embrace. In the warm, shallow seas of the early Earth, where complex chemistry could unfold, protected from the harsh radiation of space. Water provides the medium in which the molecules of life can move and interact, dissolving nutrients and carrying away waste, allowing the intricate chemical reactions of metabolism to proceed. Our cells are essentially tiny water balloons filled with carefully orchestrated chemistry, and our bodies are roughly 60% water by weight. We are, in a very real sense, walking oceans. Water shapes not only life but also the very geography of our planet. Glaciers carve valleys and transport enormous boulders like slow-moving rivers of solid water. Waves sculpt coastlines, creating beaches, cliffs, and sea caves through their endless rhythmic action. Rivers meander across continents, carrying sediment that builds deltas and floodplains. Even deep underground, water dissolves limestone to create vast cave systems, hidden cathedrals of stone decorated with stalactites and stalagmites, built drop by patient drop over thousands of years. The sound of water, whether the gentle patter of rain, the babbling of a brook, or the rhythmic crash of ocean waves, has a uniquely calming effect on the human mind. Scientists believe this response may be hardwired into our brains, an evolutionary memory of water's life-giving properties. The sound of flowing water signals safety, fertility, and abundance, qualities that our ancestors would have recognized as essential for survival. Life itself arose in water's embrace. In the warm, shallow seas of the early Earth, where complex chemistry could unfold, protected from the harsh radiation of space. Water provides the medium in which the molecules of life can move and interact, dissolving nutrients and carrying away waste, allowing the intricate chemical reactions of metabolism to proceed. Our cells are essentially tiny water balloons filled with carefully orchestrated chemistry, and our bodies are roughly 60% water by weight. We are, in a very real sense, walking oceans. Water shapes not only life but also the very geography of our planet. Glaciers carve valleys and transport enormous boulders like slow-moving rivers of solid water. Waves sculpt coastlines, creating beaches, cliffs, and sea caves through their endless rhythmic action. Rivers meander across continents, carrying sediment that builds deltas and floodplains. Even deep underground, water dissolves limestone to create vast cave systems, hidden cathedrals of stone decorated with stalactites and stalagmites, built drop by patient drop over thousands of years. The sound of water, whether the gentle patter of rain, the babbling of a brook, or the rhythmic crash of ocean waves, has a uniquely calming effect on the human mind. Scientists believe this response may be hardwired into our brains, an evolutionary memory of water's life-giving properties. The sound of flowing water signals safety, fertility, and abundance, qualities that our ancestors would have recognized as essential for survival.
In many cultures, water is seen as a symbol of purity, renewal, and transformation. Baptisms use water to symbolize spiritual rebirth, while meditation practices often focus on water's flow as a metaphor for the movement of consciousness. These traditions recognize something profound about water's nature, its ability to cleanse, to carry away the old and bring in the new, to adapt to any container while maintaining its essential character. As you prepare for sleep tonight, perhaps listening to the gentle sound of rain or simply aware of the water flowing through your own body, take a moment to appreciate this miraculous substance. Every breath you take contains water vapor. Every heartbeat pumps water through your veins. Every thought depends on the watery medium of your brain. You are part of water's great story, a temporary arrangement of atoms that water has gathered together in the form of consciousness, allowing the universe to experience its own wonder and beauty through your eyes.